This is Gail Kovac with Gresham Barlow School District, Summer School, High School Credit Recovery, Data Reasoning and Learning Target number 10. I can determine if evidence from a data set supports a given claim. So we are going to be given some kind of data set or graph of some description, some claims about it, and we have to determine if the data supports that claim or if it's just not true based off of the data, or if we can't tell. So this graph, I like to kind of look at the graph or look at the data first and just like, what do I notice about it? What do I wonder about it? So let's read the title. It says average monthly Arctic sea ice extent. So something about the ocean's ice in the Arctic, how far it goes out, that's extent, and then average monthly, so average per month. And it looks like this goes from November of 1978 to 2020. So wow, this spans quite a few decades. Now let's look at the graph. At the bottom, I have the years, okay, and I see 1980 to 2020. And at the side, I see extent in millions of square kilometers. Okay, so that's how much of it for over time. And it looks like I've got 8 million square kilometers all the way up to 12 million square kilometers. All right, now it looks like I've got this jagged line that goes up and down, and then I've got a straight line. I bet you that's a trend line that kind of averages, right? That follows that pattern downward. It says on the side, National Snow and Ice Data Center. So I guess that's the source where this data came from. Okay, so I have a pretty good idea what this data is about. Now let me read the statement and see what it says. The first statement says the Arctic sea ice extent was the lowest recorded in 2016. So let's see, lowest recorded in 2016. All right, I'm going to look at that year. Let's see, where's 2016? Here's 2016. Let's see what I see there. All right, I see, wow, this is way down there. I see a data point there. And this kind of goes back to maybe about 8.6, 8.7, something like that across. And gosh, I'm pretty sure that is the lowest point that was recorded here. I don't see any point that goes lower. This is pretty low here for 2020, but not as low as that. This is a little bit lower. And gosh, in the previous decades, it used to be even higher than that. So I would say that, yeah, this is true based off of the given data. I looked at that year and looked at the actual data point, and that was true. Now, although this line that goes through the squiggly line, it just keeps getting lower and lower and lower. This is the trend line. This is not the actual data. This is kind of like on average where we're headed, although there's some fluctuations in there. Okay, now let's see what it says for the next one. The Arctic sea ice extent has always decreased each year from 1980 to 2020. Okay. It says always decreased, always decreased. Well, I definitely see that overall trend of decrease, right? But that's not the actual data, that's just sort of generalized data. So it looks like from here to here, that definitely went down. But look at the next year. Oh, it actually went up instead the next year. Then it went down again, then it went up, and then it went a little bit down, and then way down. So you can kind of see some years it actually went up, and then some years it just really plummeted. So it's not every single year that it decreased, although it's decreasing on average overall. It's not decreasing every single year. It's going up, it's going down, it's going back up, it's going back down. So the sea ice extent has always decreased each year. No. If it said on average it decreased from 1980 to 2020, yeah, that would be true. But every single and each year it has always decreased, that is false. That is not a true claim. I could understand if someone might think, oh yeah, it has decreased, but we got to be specific with the language right here. Since it says always and each year, that's what makes this statement false. So make sure that you take a good look at that data set before you even consider the questions. We want to make sure that you understand as much as you can from the graph or the data set first before you start looking at these claims, because the claims can be a little bit suggestive. If I had read this second one and said, oh, decrease, decrease, and just looked at this afterwards, I might have said, oh yeah, I see decrease, that's true. Look at the graph first. What do you notice about it? What does it contain? What do you understand? What don't you understand about it? Try and wrap your head around that as much as you can first, and then consider those questions, whether or not the data does or does not support those claims.